Welcome back, my dear friends. Let's continue with chapter 12 mathematics for class 12. Chapter 3 class 12 mathematics matrices. Exercise 3.3, the second part. Here, yesterday we had discussed, in the first video, we had discussed about transpose of a matrix. Now, in this second part, we'll be learning about two more matrices, that is symmetric and skew symmetric matrices. Let's learn what are these matrices. Simple concept. What is a symmetric matrix? It's a square matrix. Please note it is a square matrix. That means number of rows and number of columns should be same. A square matrix A is said to be symmetric if the transpose of A results in the same matrix. That is, Aij element should be also equal to Ajith element. That is, for example, if a matrix A is given, then its transpose, if you take, that's rows to columns, 4 2, rows to columns, 2 1 by 3. What do we have here? The same matrix again, isn't it? So in that case, we will say that this matrix is symmetric. Similarly, skew symmetric matrix. A square matrix A is said to be skew symmetric if its transpose is equal to negative of the matrix. And one note that you should always remember, that is, every diagonal element of a skew matrix, symmetric matrix, is always 0. A very important note, helps us to identify skew symmetric matrices. For example, a matrix A, let's try to take its transpose. So 0 5 minus 5 0. Then if we take the negative, this is still not the same matrix, isn't it? So if you take the negative, 0 minus 5 plus 5 plus 5 minus 5, so this is the same matrix A. So that is negative of the matrix A. Some theorems which I'll not prove here, but some important theorems for this exercise, that is, for any square matrix A with real number entries, we should always note that the matrix, when added with its transpose, will always result in a symmetric matrix. And secondly, the matrix, when it is subtracted to its transpose, will result in a skew symmetric matrix. That means, for example, if you have a matrix A, and from this matrix, if you need a symmetric matrix, all you have to do is add it with its transpose. You will easily get a symmetric matrix. If you want a skew symmetric matrix, subtract it to its transpose, you will get the skew symmetric matrix. That is, if you have any matrix, it's not difficult for you to find a symmetric and a skew symmetric matrix. The next theorem is every square matrix can be expressed as a sum of symmetric and skewed symmetric matrix. Mathematically also it can be proved. I'll not do the proof here. That is, a matrix A can be written as half of, we have just studied on the previous theorem, this is a symmetric matrix, and half of a skew symmetric matrix, P plus Q. These are the letters that we use generally to denote. Moving on to the exercise quickly. Exercise 3.3, show that the matrix A is a symmetric matrix. So let's try to take the transpose. Rows to columns, 1 minus 1 5, rows to columns, minus 1 2 1, rows to columns, 5 1 3. Check, isn't it the same matrix? I believe it is the same matrix. One same, second row also same, third row also same. So this is also symmetric. Moving on to the second part. Show that the matrix A is skew symmetric. So let's take its transpose. Again, transpose. So rows to columns, 0 1 minus 1. Second row to second column, third row to third column. Now I believe these two matrices are not alike, not equal. But if we take the negative, what happens? Then 0 plus 1 minus 1, minus 1 0 plus 1 plus 1 minus 1 0. Then I believe these two matrices are equal. 1 same same. So that's negative of the matrix A. So it verifies that it is a skew symmetric matrix. Moving on to question number 8. For the matrix A, verify that. Let's do verification of the theorem. That is number 1. So a matrix A is given 1 5 6 7. Let's try to get its transpose. 1 5 6 7. So now the first part is you have to prove that A plus A. Let's denote this by maybe not P, X, this matrix. So let's add 1 5 6 7 plus 1 6 5 7. So 2, 5 plus 6, 11, 6 plus 5, 11, 7 plus 7, 14. Now we have to prove that this matrix X is symmetric. So let's try to get its transpose. 2, 11, 11, 14. I think it's the same matrix, isn't it? So therefore x dash equal to x, which implies A plus A transpose is symmetric. Similarly, the second one, A minus A transpose. Let's try to find out A minus A transpose. 1, 5, 6, 7 minus 1, 6, 5, 7. Remember one theorem which states all the diagonal elements of a skew symmetric matrix should be 0. Exactly so. 1 minus 1, 0. 7 minus 7, 0. Isn't it? 5 minus 6 minus 1. 6 minus 5, 1. Let's denote this by y. Now let's get its transpose. 0 minus 1, 1, 0. This is not the same, but if we take a negative, 0 minus 1 plus 1, 0. I believe it's the same matrix, y. So y transpose is equal to minus of y. Therefore it is skew symmetric matrix. So this exercise is simply based on the concept of transpose, skew symmetric and symmetric matrices. So in the next video I'll do 1 or 2 more questions from this exercise, and then we'll move on to inverse of a matrix. So I would request you to share these videos with maximum of your friends and tune in for more videos so that we can help you at the most. Thank you so much. Signing off from the team of Teach Nagaland.